do we find the derivative of a product of functions? Well, we have the derivative with respect to x of f of x times g of x is equal to, okay, based on our limit definition of a derivative, then we have the product of f of x plus delta x times g of x plus delta x minus the product of f of x times g of x all over delta x. What I'm about to do next is going to seem really strange and completely out of thin air. But remember, the mathematicians that were working on these proofs, they had to try anything and everything to try to manipulate into what they knew. So we are going to follow what they did in order to manipulate this problem into something that we actually can understand. In the middle of copying this down, I'm going to subtract the quantity f of x plus delta x times g of x Now I just came up with this out of nowhere, / from the textbook, but if I subtract a random quantity, I also need to add that random quantity in order to do it mathematically. So now we're going to add f of x plus delta x times g of x. In the numerator, we still have subtract the product f of x times g of x. All of that is over delta x. At this point, the first term has an f of x plus delta x, and the second term has an f of x plus delta x. The third term has a g of x, also an f of x plus delta x, but not relevant here. And the fourth term has a g of x. I'm going to split the limit at the same time. I hope you don't mind. Now in this first fraction, I'm going to have the first two terms, so f of x plus delta x times g of x plus delta x minus f of x plus delta x times g of x all over delta x. Our third term is f of x plus delta x times g of x subtract f of x times g of x all over delta x. So we'll factor out f of x plus delta x, and we'll times it by the fraction g of x plus delta x minus g of x all over delta x, plus the limit as delta x approaches 0. Take out the g of x times whatever this fraction is. And here we've factored out g of x. Now I'm going to take the limit of each of these products. So if you have the limit of this product and the limit of this product, you can rewrite it as the limit of the first item times the limit of the second item. So you have delta x approaches 0 of f of x plus delta x times the limit of g of x plus delta x subtract g of x all over delta x, which is the definition of g prime of x. Then we'll add that. Here you'll have the limit as delta x approaches 0 of g of x times the limit of this fraction, which is actually another way of writing f prime of x. The limit as delta x approaches 0 of f of x plus delta x, when you plug in 0 for delta x, that's f of x plus 0, which is f of x. So we're left with f of x times this right here is g prime of x plus the limit of g of x as delta x approaches 0. There is no delta x in there, so it remains g of x times f prime of x, the definition of the derivative of f. This right here is the beautiful product rule. So the derivative of a product of functions is equal to the f function times the derivative of the g function plus the g function times the derivative of the f function. My college professor recommended a way of memorizing this that just stuck with me. So I'm going to teach it to you as well. So he would pronounce this as f times the derivative of g. So f dg plus the g function times the derivative of the f function. Okay, so this is how he would say it. F dg plus g df. F dg plus g df. F times the derivative of the g function plus the g function times the derivative of the f function. So I want you to pause the video and say this out loud 10 times. And I'm not 100% sure that you're going to do it or that all of you will do it. So I'm going to do it for you as well. What is the product rule? FDG plus GDF. The product rule, you say? FDG plus GDF. 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 Okay, let's use it now. For our first example, we need to recognize what is the f function and what is the g function. What two functions are being multiplied here? So we have y is equal to 3x squared times sine of x. So the first function is 3x squared. We'll call that f of x. And our second function is going to be called g of x, and that would be sine x. Now remember, 3 times x squared, that's just a constant, so that doesn't, that's not another function or anything. So now we're going to use the product rule. F dg plus gdf, f dg plus gdf. So the derivative of y prime, would be the f function times the derivative of the g function plus GDF. So plus the g function times the derivative of the f function, 3x squared. Now it's time to evaluate. What is the derivative of sine x? So we have 3x squared is going to be multiplied by the derivative of sine x, which we learned yesterday is cosine x, plus sine x is going to be multiplied by the derivative of 3x squared. This is a polynomial, so pop down, power down. 2 times 3 is 6. X to the subtract 1 from the exponent, and that is the derivative of 3x squared. So our next step is just to do some algebra to clean it up. So this would be 3x squared cosine x. Put the 6x as the coefficient for sine x, so 6x sine x. No like terms or anything, and that's the derivative using the product rule. Let's do another one. Y equals, you have 2x, that's a function. X having an input means it's a function. So 2x is a function times cosine x is a function. But then we have more stuff over here. So do we have two products going on? No, this is just 2 times a function. So here you have a product. You could say f of x times g of x but then you're also subtracting some other function, right? So we use the subtraction rule for derivatives as well. But our actual focus will be f of x will be 2x, and g of x will be our second, because we are only worried about the product here. We will figure this out. Y prime is equal to f dg plus gdf, f dg plus gdf, f times the derivative of g plus g times the derivative of f dg plus gdf, f dg plus gdf. 2x, so f dg, 2x times the derivative of g. Plus gdf cosine x times the derivative of f, 2x. But we're still subtracting this 2 sine x. So 2 sine x would be 2 times, we can take the 2 out, so 2 times the derivative with respect to x of sine x, because 2 is a constant. Y prime is equal to 2x times the derivative of cosine x is negative sine x, plus cosine x times the derivative of 2x. Well, the derivative of x is 1, so 2 times 1 is 2, minus 2 times the derivative of sine x, which is cosine x. Y prime equals, now we're going to clean it up, so negative 2x sine x plus 2 cosine x minus 2 cosine x. Oh wait, that's 0. So it's going to simplify even more to negative 2x sine x as our derivative.